Now that we are done placing our nodes, connecting and enabling the morphs, we will finalize our work. We will now expand the boundary of our widget. The boundary was created to be expanded in increments of 100 across the x-axis. If you remember, when we started the eyes group, we moved the brows group -1 inch to the left to get it out of the way. The widget was designed for the groups to be moved in increments of 1 inch to the right so that when you scale the boundary by 100, it encloses the groups evenly. Since we have these groups here, we need to make the scale across the x-axis 300 to evenly enclose the groups. Across the y-axis, however, we need to scale by increments of 125. This is because the groups themselves are longer across the y-axis. What is required is that each group is moved down the y-axis 1.5 inches in order to maintain a nice even look. You can now see as we move a group down the y-axis by 1.5 inches and scale in increments of 125, we continue to maintain a clean look. I know that the scale factors of the x and y axis are different. It was unavoidable in the development process. As we continue on, we are going to turn on compensate and dynamically parent the group locator labeled F.C.S. 2D nodes to the locator labeled F.C.S. type 2. This is the container we created that houses all the 2D nodes we worked on in the previous videos. This is not necessary to do for the F.C.S. 3D nodes group locator. If we don't use compensate when we dynamically parent the F.C.S. 2D nodes to the locator labeled F.C.S. type 2, it will relocate the group locator, and we do not want that. Now we're going to move the widget in relationship to the figure. In this case, we want to move the widget 5 inches in the x-axis and 5 feet 6 inches on the y-axis because that's a good location in relationship to the head. Here, we are looking at some more reasons on why we need to do certain processes. As you can see, when we rotate the head, the nodes we've created are not aligning themselves to the mesh. If we dynamically parent the F.C.S 3D nodes group locator to the head joint, this issue is fixed. However, if we dynamically parent the F.C.S group locator, we solve the alignment issue of both the 3D nodes and the widget. Remember, we need to have compensate on. As we can see now, when we rotate the head, the 3D nodes align themselves to the mesh and the widget matches its rotation angle. Now we'll label the system. You can see the widget is no longer red, but instead green. We can also see that the morph control location nodes have disappeared. We will go ahead and deactivate the system. When the system is deactivated, we can move the location of the nodes parented to the widget. Since the 3D nodes are apositionally constrained, they cannot be moved from their location. Let's reactivate the system. We can see the controller nodes are controlling the 3D nodes on the face. We'll be finishing up in the next video.